Hi, everyone. Welcome to today's webinar. Today, we're going to be focusing on discussing basics of decarbonization and some strategies that may be considered while developing projects. Before we get started, I just have a few housekeeping items for us today. At the end of the presentation, we will have some time reserved for some question and answers. So if you have any questions throughout the duration of the presentation, please make sure to put those in the chat box and we'll answer all those at the end. As you may have just heard, this webinar is being recorded, so we will be placing this webinar as well as the slide deck on our website so that they may be viewed later on. And I will drop the link to our decarbonization webpage in the chat so you all have that. And with that, I'll pass it over to the NORESCO team. Thank you.
Thanks, Melissa. Hi, everybody. I am Michael Goodrum with NORESCO. We are one of the consultants that is supporting the decarbonization aspects of the DRI and New York Forward programs. I have with me today Michelle Scordino, that's part of the NORESCO team, and we're going to go through what we've sort of labeled Decarbonization 101, and a brief agenda of what we'll talk about today. We will start with some background of, what is decarbonization and why. We'll talk a little bit about what decarbonization compliance looks like in the DRI and New York Forward programs. And then we will dig into some of the different strategies for decarbonization in buildings and end with time for some questions, hopefully. There's quite a bit of material here, so we'll do our best to get through and leave some time at the end for questions from folks. To get us started, some key terms for everybody, just so that we're all on the same page. These are, maybe familiar with for some of you, but starting out with greenhouse gases, those are gases that trap heat in the atmosphere. And then decarbonization is really just the reduction of carbon emissions or greenhouse gases. And then focusing specifically on building decarbonization, that is the mitigation of these greenhouse gas emissions through the reduction of building energy demand, followed by converting your existing equipment and systems, if you're an existing building, especially those that are fossil fuel combustion, to highly efficient equipment and systems. And then, maybe the next step beyond building decarbonization, or a component of it, building electrification, is shifting fossil fuel heating or cooking to using electricity. Another component of building decarbonization is embodied carbon, which are really those greenhouse gas emissions that are part of the manufacturing and transporting, installing the various building materials that go into construction for a building or renovation. And ultimately, for the state and for many programs, and you've probably heard, is moving toward carbon neutral buildings. And a carbon neutral building is one where your design, your construction, and your actual operation of the building don't contribute additional greenhouse gas emissions through their life. And then a last term that we've got here related to building decarbonization, and something that's, getting, I think, more attention now, is resiliency and resilient buildings. And those, building decarbonization is a part of that, and building resilient buildings. And they're designed just to protect health, safety, comfort of occupants, and help keep them, buildings operating and occupants comfortable, even in the event of, or like even in extreme events or power outages and things like that. As far as New York specifically, New York has the Climate Leadership and Community Protection Act, or the Climate Act, which sets out a goal to reduce carbon emissions by 85% by 2050. And As you can see, about 70% of the state's electricity is generated, or one of the goals is 70% of the state's electricity generated by renewable energy by 2030, which is coming quickly, and then 0 by 2040. And that, you can see here that buildings make up about 1/3 of the emissions for the state. And so moving buildings toward electric systems, electric uses, and with the shift in the state's electricity generation, will move the state toward its goals for reducing these emissions by 2050. And so the DRI New York Forward programs are part of that in contributing toward the state's goals. When we talk about building decarbonization, one of the benefits and one of the things that a lot of folks would consider are the economics and looking at the utility cost savings and utility costs even. So we've kind of outlined two components of utility costs and savings that are associated with building decarbonization. The first being energy efficiency, where you're improving the efficiency of systems, and basically getting the same amount of light or the same amount of heating or cooling for less energy. And by reducing the energy use for those things, then you end up reducing your associated energy costs because you're using less energy. Building electrification, that we defined just a couple slides ago, where you're moving from fossil fuel to electric sources, will reduce or you can even eliminate fossil fuel utility costs, but then it also increases electricity costs, and that may or may not result in savings, and a lot of that really depends upon what the utility costs for those the fossil fuels versus the electricity are, and those are changing over time. So at any given time you have to sort of evaluate, but just because you implement a building electrification measure doesn't necessarily mean that you are going to lower your utility bills. Some of that depends on the associated costs with the different utilities. Other benefits related to decarbonization between, besides potential cost savings, are, and we don't have to go through all of these, but things like health benefits, with electric systems that don't have emissions from combustion that are, exhausted into the building space. We talked about resiliency before, and including some of the strategies that we'll talk about today can help your buildings better weather extreme events, right, and remain comfortable, remain in operation. And, even things like improved comfort for occupants, where you have increased airflow or movement or things, or even in some cases, depending on where you are, places that may have only been heating only previously, with installation of heat pumps, you can have some cooling capacity for some of those days where it does get a bit uncomfortable inside. So there's a variety of benefits to building decarbonization as we start to talk about the different strategies here. Now we'll look at briefly the compliance or the building decarbonization within the DRI and New York Forward programs. And this compliance matrix outlines, which project types, which building types that those requirements apply to. It's pretty straightforward. Simply put, if it's a project that's over 5,000 square feet, whether it's something, new construction or a renovation, then you would need to meet the decarbonization requirements of the program. And then if you are, less than 5,000 square feet, or maybe don't meet the more detailed definition of a renovation, we won't get into that here, but you can still choose to opt in and pursue various forms of decarbonization, even if you're not required to meet it for the program itself. And if you are required to meet it, we have 3 compliance paths for decarbonization outlined that projects can select from. The first being complying with the New York Stretch Energy Code, which is about 10% more efficient than the state's base energy code. And you can meet that one of two ways. The first being following prescriptive improvements, which means you have, for example, building envelope that's there, it'll specify certain R values of insulation you need to meet, things like that. Or you can pursue a performance-based path where you can demonstrate whole building performance with an energy model and show that your energy use per square foot is, below a number specified in the code for your building type. A second option is an Energy Star path, which makes use of Energy Star's Target Finder software, which is associated with their portfolio manager program. And in this case, you would achieve an estimated score of 90 or better. Target Finder, you enter in some basic building information and project out a year's worth of your building's energy use, and then it will generate the expected score for you. I know there's been news about the Energy Star program. As far as we know, it still exists, and so this is still an available compliance path. If something changes in the future, then we'll probably make some adjustments in the program. But for now, it remains a viable option. And the last would be meeting a third-party certification or pursuing a third-party certification. We have a list here of approved certification programs. One that a lot of folks are familiar with is the LEED program. So if you had a building that you were already planning to pursue LEED certification, maybe for a different reason, that could be a good path, good option. And so each of those are available compliance paths. The only other thing I note in that third-party certifications up at the top, Building Cleaner Communities Competition, which is a NYSERDA program, is an acceptable form. That program is run, or the kind of applications are done through the CFA for the state, which I believe is still open through the end of July. And so, or for this current round. So, if that's something of interest, you could always look at the CFA and see if you could get an application in the next month. But there should be another round next year. So, and then last on the compliance section is a lot of folks ask, what's the best path for my project? This is a table showing kind of, highlighting areas where different paths line up for different project characteristics. Some examples are for the prescriptive path, if you're doing a renovation, you only need to meet the prescriptive requirements for whatever systems or components you're actually upgrading. And so it can be a good path for renovations or, especially things like historical buildings where maybe you have limitations on what you can do, like maybe are unable to change out windows or things like that. They get excluded from having to meet the stretch code. If you're thinking, or if you were planning to do like a whole building energy model or something, the New York Stretch Performance Path or Energy Star could be good. And then like we said, if you're already thinking of doing, say, LEED, that could be another, or reason to do the third party. So each of them has pros and cons, but we designed the program so that there's some flexibility for projects to choose from, and to find the path that best suits their project and meets their needs. And now I will turn it over to Michelle, and she will start to walk us through some of the ways of how we pursue building decarbonization in our projects.
Thanks, Michael. Yes, as Michael said, so we're discussing decarbonization, especially in the context of DRI New York Forward, with the majority of projects being buildings. So we'll focus primarily on some building systems, but also wanted to mention here as well that transportation also is another key component of decarbonization. And there are some projects that touch upon that as well. So really we'll kind of look at new buildings, existing buildings, and then also just mention transportation here as well. So how do we get to decarbonization is kind of the first focus of this part of the presentation. Main focus is for new buildings, integrating more efficient designs than required just by the New York Building Code. Also incorporating electrification solutions, improving the building envelopes, which we'll discuss in greater detail, especially greater interactivity, and then integrating clean energy sources, whether that be on-site or off-site. For existing buildings, we'll discuss retrofits for existing systems, as well as building envelope upgrades, which may look different than for new buildings, and then also clean energy sources. For transportation, decarbonization is accomplished both through the reduction of miles driven, as well as through alternative fuel vehicles, such as electric vehicles mainly, and also using alternative modes of transportation and incorporating EV charging stations, and also ride sharing and and public transportation as well. So again, focusing on buildings, new buildings versus existing buildings. New buildings, it kind of starts from the beginning of from the conception of a project and integrating decarbonization into all aspects of a design. So integrating passive lighting, heating, and cooling. We can look at electric systems for both heating and cooking appliances as well. Integrating high performance building envelopes into the building, lowering the load of the building, and again, using more efficient systems than required by the base energy code in New York. For existing buildings, a big concern, I guess you could say, is constructability. So given that you've got a structure of a building, you have to think about backfitting into existing systems. Envelope improvements, again, may be somewhat more challenging for existing buildings than for new buildings, but you can still achieve pretty high building envelope performance through renovations. Focusing also on minimizing disruption to occupants in occupied or partially occupied buildings. Building in contingencies into the construction process, knowing that things come up and you're dealing with an existing building, which may require different workarounds than maybe anticipated at the setting out at the beginning of a project. And then also thinking about the economics, there's decarbonization strategies may cost more in some cases, as Michael previously mentioned. However, there's also a great payback oftentimes with higher efficient equipment as well. Some steps for decarbonizing a building include, first, understanding your current or projected energy consumption. This is very important so that you have a good handle on, if for existing buildings, how your building is using energy, or for a projected building, how a new building, how do you anticipate this building to use energy? Once you have a good understanding and basis of how the building is going to or currently uses energy, you can then look at reducing loads and maximizing energy efficiency into the building. And then thirdly, integrating building electrification strategies. So either through equipment or other appliances. And then as kind of fourth, then integrating building automation systems to further maximize the efficiency of your building. And then fifth, incorporating distributed and renewable energy resources, whether again that be on or off site that you're accessing those renewable energies from. And then sixth, adding energy storage systems, which also increases the resiliency of the building. And then finally, addressing embodied carbon. Looking here at some attributes of a decarbonized building. Decarbonized buildings, they maximize energy efficiency. They work, you know, just holistically, kind of understanding your building and how it's using energy. Decarbonized buildings also favor electric end uses over fossil fuel combustion to lower the emissions associated directly with the building itself. You can also produce or procure your own zero emission electricity. So through solar panels, for example, or also procuring your energy from offsite, such as community solar systems or also community wind turbines. Fourth, also, decarbonized buildings are designed with flexible loads and storage as well that can respond to grid conditions. So for example, if you have a solar system that's also working with a battery system and the power goes out, you have that backup energy to continue meeting all the demands of your building. Fifth, thinking of resiliency. So again, what I just mentioned is a resilient measure. So if you have your own energy that your building's producing and your building's all electric and you have a battery system, when power goes out, if you've charged that battery, then your building is set. So that's an example of a resilient building. And then finally, designing with attention to embodied carbon, as well as low global warming potential refrigerants as well. So the next section here, we're going to take a deeper dive into some strategies for decarbonization, and we'll hit kind of 4 main categories. The first being load reduction strategy. So we'll go through some high performance building envelopes, LED lighting with occupancy controls, energy recovery ventilation, which can optimize your heating and cooling demand, as well as smart electric appliances. Next, we'll move to building electrification, which will include making sure that a building has the sufficient electrical capacity and service to meet the building demands. We'll talk through cold climate, air, and ground source heat pumps for both space heating and cooling, as well as heat pump water heaters with storage tanks and demand flexible controls. Electric induction cooktops and heat pump dryers, and then moving on to advanced controls, we'll also discuss some load flexibility and advanced controls of hot water, HVAC, and other smart appliances. And finally, conclude the section with distributed energy resources such as solar panels, bidirectional EV charging, and thermal storage. So first here, to kind of define what load reduction means, we're focusing here on 2 building load reduction. So electric load, which is the amount of electricity required to operate any electric appliances or HVAC lighting in the building, as well as plug loads, which are things that you plug into outlets. As well as the second kind of load reduction area being heating and cooling load, which is the amount of heating and cooling required to maintain spaces comfortably for occupants and equipment. So within those kind of 2 areas of load reduction, we'll look at high performance building envelopes, LED lighting with occupancy controls, smart building systems, energy recovery, ventilation, and then maximizing efficiency with your systems. So the first area of load reduction, we'll look at high performance building envelopes. Now, I've mentioned building envelope a number of times already. And so to define that, I just want to say that the building envelope is really any component that's going in your building that's going between conditioned and unconditioned spaces. So typically this is going to be your exterior walls and windows and doors, which would include also the insulation, your framing, the drywall, exterior surfaces of your building as well. I also want to call attention specifically for New York that in heating dominated climates, high performance building envelopes significantly reduce the energy loads on your building. So there, especially for existing buildings, making envelope upgrades are very important. There's a lot of leaky buildings out there and a lot of wasted energy just because of heat loss in and out of buildings. And so focusing on high performance building envelopes is really key to driving down the loads of your building. Also, I want to note that with one of the main paths that of decarbonization compliance being the New York Stretch Code, I wanted to note that New York Stretch does require improved efficiencies compared to the base energy code for building envelope performance factors. For example, the windows and insulation and as well as thermal bridging are more stringent in the New York Stretch Code than is required by the base energy code. So some components of the high performance building envelopes would include insulation, so roof insulation, wall insulation, as well as thermal bridging, which you can kind of see in this diagram, but really it's adding in insulation and continuous insulation where there might be heat loss through framing, for example, in your walls, and that is something that we won't dive into deeper here, but want to bring to your attention because that's something that we can also help further with projects one-on-one, understanding what that looks like and how to apply it in your building as required by the New York Stretch Code as well. The next load reduction strategy is LED lighting with occupancy controls. So lighting is something obviously all buildings need, and LED fixtures have made driving down lighting loads much more possible than in the past. But then also pairing LED fixtures with occupancy sensors to turn lights off and on, either from sensor controls or through timers, can really drive down also the lighting loads on your building. In addition, using natural lighting such as skylights and strategically placing windows to bring in more natural light can also bring down some of your lighting loads in a building. Next, we'll look at smart building systems. Smart building systems automatically schedule on and off times for appliances and machines and other plug loads in your building, reducing energy when they're not in use. So potential applications might include appliances, vending machines, computers, and plug loads, which can be very helpful, especially in office spaces when you're turning off scheduling to turn off computers and plug loads at night, really driving down the kind of unused energy loads that are common in buildings, especially in office buildings. The next one, ventilation strategy. So we have kind of two ventilation strategies we'll be discussing here. So the first one is ventilation air. So the amount of air that you're bringing in and out of the building. So by reducing the amount of air that you're building into to what is actually necessary for the building, you can really limit what you have to what your HVAC equipment has to condition. So some strategies for this can be using natural ventilation, demand control ventilation, which is based on sensors determining how much is actually needed in the building, and then also using circulating fans, which move around the air so the air in a building isn't stagnant, but it's not necessarily bringing in external air at all times. And then additionally, reducing losses through the ductwork of your ventilation So insulating ductwork and piping, and then also air sealing ductwork as well makes a big difference in regards to energy loss for ventilation air. And I believe we've got this one and one more. So the next being regarding also ventilation is using energy recovery ventilation, which energy recovery ventilators are an added piece to your HVAC equipment where a heat exchanger preconditions your incoming outdoor air with the exhaust air from your building. So if it's in a heating season, your hot air that's going out, and as you're bringing cold air in, those two air streams pass, and you're able to preheat that air coming into your building so that your HVAC equipment itself doesn't have to do as much to get your supply air temperature to the required temperature for distributing to the building for heating. This can be in, as I said, integrated in your HVAC, ducted HVAC system, as well as you can incorporate various configurations, such as in your domestic hot water systems as well, using hot water to also preheat your incoming air, for example. Yeah, particularly important for New York Stretch.
I don't know if it was just me, but we lost you there for a second.
Oh,
Michelle.
okay. Oh, thank
Yeah,
you. Can you hear me now?
We missed what you said about the New York Stretch.
Oh, okay. Okay, just wanted to note that energy recovery ventilation is required by New York Stretch in many of the building applications. So not all, but something that want to particularly bring to your attention as your projects are designing their HVAC systems. And then you can move to the next one. In addition to ventilation loads, we've also got domestic hot water load reductions. Domestic hot water can be directly reduced through lowering supply temperatures, or also indirectly by reducing the losses and loads of the equipment. So we recommend lowering domestic hot water supply temperatures for systems that might be exceeding what is actually necessarily for distribution. So kind of aiming at the lower end of what's required for heating, such as which is typically 120 to 130, and then lowering that, using the lower end of 120. Also using high efficiency faucets and shower heads as well to limit the amount of water that's just kind of going down the drain, as well as domestic hot water heat recovery. So similar to energy recovery ventilation, you can also use heat recovery for your drain water. So as your hot drain water is going out, you can precondition your cold incoming water through the heat from what's outgoing. And then similarly to ventilation, again, reducing losses in your piping through insulating your water heater tanks, as well as the domestic hot water piping.
I think we lost Michelle. So I'll pick up the last piece here in the load reductions and looking at maximizing efficiency, especially of your HVAC systems, are two different forms of commissioning strategies. There's Retro commissioning and recommissioning. So retro commissioning would be if you had a system that was installed but never commissioned, and basically the commissioning process is going through and testing it all and making sure that it's operating the way it was designed to. The things turn on or off when they're supposed to, or things adjust to certain levels when they're supposed to. And if that's never been done, your building may not be operating as efficiently as it can. And by doing a retro commissioning process, you can go through and take the systems and make sure that they are working the way they were originally designed to, which can bring a lot of efficiency improvements. The other is recommissioning. And that would just be a system that was once commissioned, but maybe it's been 10 years, 15 years, and nobody has been paying as close of attention to it since, and so it's not operating as well as it had been when it was new. You can go through and essentially repeat the commissioning process and restore things to working in the way they were designed, and improving the efficiency of the systems in that way. After the load reductions, the next step, as you saw in that the slide Michelle covered, is moving into building electrification. And we defined that before, moving away from fossil fuel fired systems to electric powered systems, especially for heating and cooling. Some common areas that we'll talk about, and we'll start actually talking about electrical capacity, which is not really a specific strategy for heating and cooling, but is an important foundation for the other strategies we'll talk about. And then looking at heat pumps for space heating and cooling, as well as water heating, and last, electric appliances. So before talking about electrification, an important piece of it is the electrical capacity. And this is primarily a concern for existing buildings where you're doing a renovation. Obviously in a new construction situation, you can build for the capacity you need. But for older buildings, and especially, if you've got one maybe that's even like a historical building, things like that, their old electrical infrastructure was designed before a lot of the electric loads we have now, even down to things like computers and like television screens everywhere and stuff like that. And so the capacity may not be sufficient for, switching from, say, like a fossil fuel fired HVAC system to an electric heat pump based system. And so going through and getting your building to what we might call electric ready, and it's kind of noted here, there's no savings from this. We talked about utility cost savings before. Getting to an electric ready standpoint, unfortunately, is just a cost. It's not necessarily going to save you any energy, but it will set you up to be able to implement some of these other strategies. And that can include doing an electric demand analysis, basically looking at all your electric loads, how much they use, and how does that compare with your capacity. And then if you need to, pursuing a utility service upgrade. And so we are talking about this now at the front, just because if you do need a utility service upgrade, that can be a pretty lengthy process, and you'd want to get started on that now, doing your study, making sure you have the capacity, or if you need to, pursuing other upgrades so that they don't slow you down from being able to implement other strategies. Another important consideration for building electrification when you are doing a renovation project is the heating hot water temperature of your system. So for a lot of existing buildings and that are running on a fossil fuel fired system, they'll be running at a higher hot water temperature. So if you've got a lot of radiators for heating, like the one that's in the picture, you may be running with a hot water temperature of, say, 180 degrees Fahrenheit. And if you're looking at replacing that with something like, say, an air to water heat pump or something, a heat pump based system, most heat pump based systems produce hot water at a lower temperature. A lot of them are in the like 120 to 130 Fahrenheit range. which would be considerably less than, like the 180 of an existing system. And so making sure that you can still heat the building properly if you're going to make that switch. That can include, some strategies for making it work can include making adjustments to the system so it can operate at lower temperatures. So that might mean, expanding coils or, adding additional ones to help transfer heat and, get the temperatures that you want in a space. They also do make high temperature heat pumps. Those have made a lot of progress in the last like 5 years. And so you can go find heat pumps that will produce hot water at higher temperatures. I think they may get up to 180 now. 160 is pretty common. They do cost more than ones that are in the kind of normal 120 to 130 range. But that might end up being cheaper than, say, adding other equipment to help meet the heating loads in your building. Another is what they call cascading heat pumps, which is where you kind of take two heat pumps and pair them together. And, the example here would be like an air to water heat pump that is serving water source heat pumps. And that's a way that you can kind of get a multiplier on the temperature and produce some higher temperature hot water than you would with just a single heat pump system, or using boilers or things. And even in a lot of cases, you may still be looking at including boilers to supplement for peak days anyway, in certain parts of New York where temperatures get down pretty cold on some of the peak days. So addressing the hot water temperature of the system is another key piece. And once you've looked at electrical capacity and the maybe hot water capacity, however temperature capacity for your system, then you can move into the heat pump technologies for electrification. First, for space heating and cooling, and for New York, looking at cold climate heat pumps. They continue to make progress and improve performance of these heat pumps at lower and lower outdoor air temperatures. I know that was initially a concern for a lot of folks, that they may not perform well when it's 5 degrees outside. Now they have a lot of heat pump systems that will perform well down at those low temperatures. And you can see a link there in the bottom corner with for the Northeast Energy Efficiency Partnerships, or NEEP, cold climate heat pump guide or list. And that actually, they maintain an updated list of various heat pumps that are made to work in the colder climates for the Northeast. And we've got some different technologies listed here for heat pumps. Air source are the ones that are most affected by the outdoor air temperature. The variable refrigerant flow, or VRF systems, typically have some kind of air source heat pump serving them. But there are systems that allow you to actually do energy recovery between spaces or rooms. So, like if you had, for example, a mixed use building where you had like a restaurant in one place, and then you had, I don't know, like a flower shop in another spot, and the restaurant has a lot of heat and the flower shop needs heat, you can actually, in a VRF system, transfer the heat that you're trying to get rid of in the restaurant and use it to maybe heat the flower shop in the wintertime, say. Others are water source heat pumps, which just use a water loop. So they're kind of independent of the outdoor air temperature. And then you have something to kind of heat and cool and maintain the temperature of that water loop. One of those things could be a ground source heat pump system. The last one you see, these are typically the most efficient of all of the heat pump systems. The drawback being they have a high installation cost because you got to dig trenches or drill holes in the ground to put in your piping for heat transfer with the ground. But the ground keeps a pretty steady temperature, so in the winter it's warmer than the outside, and in the summer it's cooler than the outside, and so it makes a good way to heat and cool from that source. The other item for are another item for electrification. Heat pump water heaters. These are, working very similar to the space heating and cooling, except instead of heating up air, they're heating up water. And they work, now they've made a lot of improvements. You can see the picture here, that looks like a tanked water heater you might find in a normal, apartment or house or something like that, small commercial building. And most of these now are made to plug in directly to 120 volts. The early ones were 240. And so they're pretty accessible. Some things to keep in mind for these are that they can be noisy, definitely noisier than a typical, than like an electric resistance or a natural gas fired water heater. If you think about like the air conditioning unit with the fan outside that's running, you basically have something like that running here with the heat pump. So you've got some noise when it's running. The other thing is that they need a lot more room for ventilation. So either you need a bigger space for the water heater to be in, or you need some form of ventilation, whether it's like piping to the outside or vents cut in the room or something like that. Each manufacturer kind of has its own specifications for that, but those are two things to think about. One thing that's noted here, demand flexible controls. These heat pump water heaters, and really any water heater with the tank system, you don't need to heat them all the time constantly. It'll heat up and then store that hot water for a while, and then you have to every so often kind of warm it back up. But it means that you can schedule that so that you're not running your water heater when electricity costs are the highest or things like that, and gives you some flexibility to, heat up the water at times when it is cheaper and can help save you on energy costs. The last item, are electric appliances. These are probably, most common in like multifamily or residential type settings, things like induction cooktops, which, I know there are electric resistance cooktops, or the old, with the coils. Anyone that's ever used them, like, they're not awesome. Induction cooktops are way better and also way more efficient, so they can be a good option. And they do also make heat pump dryers. It's similar to like the other heat pump technology and the way it works. And they're a very efficient and low operational cost form for clothes drying. After the electrification strategies, then we're looking at advanced controls, and really, layering these in to help make sure that things are running optimally. That can include monitoring-based commissioning, and then kind of load flexibility, grid interactive controls. Monitoring-based commissioning, we talked about the other commissionings before. This is just like an ongoing commissioning. So you're basically doing a regular tune-up of your building systems over the life of the building to make sure it keeps working the way it's supposed to, instead of having to every 10 years do a tune-up kind of thing. And then the load flexibility or other advanced controls are, able to program, energy saving strategies in them. So like scheduling and optimizing when systems turn on and off to heat or cool, or resetting temperatures, so like when people aren't in the building in the summertime, it doesn't need to be 70. Maybe you can let it be 80 degrees and then cool it back down in the morning. Or, same with pressure, that can affect like how much fan energy you're using and stuff. And so adjusting those things to minimize the energy use of the system. Michelle talked earlier about some of the ventilation strategies, and you can use CO or CO2 sensors to control how much ventilation you need. So things like a gym that don't always have people in them, you don't need to bring in a whole bunch of outside air if there's nobody there. And then demand response, the last one, sort of what we talked about with the water heater, where you can make adjustments for times when energy costs might be higher. Say setting the temperature to 72 instead of 70, at times when energy costs are higher. So you run your system a little bit less than you would have otherwise. And those can help to layer on some additional efficiency and optimize your systems. And then the last are distributed energy resources. The main ones, or the main thing we'll talk about is renewable energy. And, we'll look at some EV charging. But I think most people are familiar with solar PV arrays in particular, and they're probably the easiest for most buildings. It's, most have enough space to incorporate some solar panels, produce some electricity on site with clean power that has, no greenhouse gas emissions when it's generating electricity. You can also do wind. That's probably less common for most buildings. The trick here is that you may have sun at times. You don't need to use as much electricity, and you may need electricity when you don't have sun. That's where some of the battery storage can come in. We're not diving into that too deep here, partially because it just can be expensive and challenging for a lot of buildings to implement. But storage definitely expands your flexibility with these systems and the resiliency for your building. A unique form maybe of battery storage that we'll talk about here briefly is bidirectional EV charging. And basically that's, electric vehicles have become pretty common and are in, most places. And really you can think of them as like a mobile battery. So if you have a situation where you have like a fleet of vehicles that is regularly at a building for an extended period of time, say like a small office or whatever, you could even take advantage of them as like a battery to, if you have a PV system and you're producing a lot of electricity in the afternoon when it's really sunny, maybe everyone drives into work in the morning and you can actually draw power from the batteries of the cars in the morning to help meet some of the building energy. And then in the afternoon, like when you don't have as much sun, in the afternoon, when you have more solar power than you can use, you can then use that to recharge the cars in the afternoon so that they're ready at the end of the day. So that's a rather quick overview of a lot of different strategies. We're getting down to a few minutes left and have a couple of slides. I think Michelle is back, and so she will help take us through the last couple of some frequently asked questions people have had in the program related to decarbonization.
Thanks, Michael. Yeah, so the first question that we've gotten pretty frequently is, how does decarbonization differ between new construction and substantial renovations? And we've covered this a bit, but some strategies are definitely easier in new construction, such as making high performance envelopes. Making significant envelope changes can be somewhat costly sometimes in renovation projects where you're not necessarily planning to really gut walls and really get down to the bones of the building. But I will note that really any envelope improvements make a difference for existing buildings, as well as HVAC distribution. So making changes to ductwork can especially be more difficult. And if you've got leaky ductwork, that might be hard to access and kind of, tighten that up for existing buildings than for new buildings. Just, install it kind of the right way and highly efficient at the beginning, as well as adding electrification into the building, which I know Michael covered a bit with some of the electrification strategies and electricity upgrades that might need to be made to substantial renovations. The next question being on historic buildings. Yes, there are often limitations with historic buildings that can cause challenges for, decarbonizing and especially kind of meeting some of the requirements for the program. However, that is not to stop you from participating in the program. If there's limitations based on historic buildings, that's something that our team works with you to address, and we can try and get you to the highest level of efficiency that is allowable for the building itself. We also did have a historic building webinar that took place earlier in June, and that recording is up on the DRI and New York Forward resources page. And then the last couple of questions is, do projects need to be all electric for DRI and New York Forward? And the answer is no. While it's encouraged, it is not required. And then finally, we've gotten the concern of electricity outages and how do you deal that if you're moving to all electric, especially heating and cooling systems, or and then also your hot water. So again, stressing on high performance building envelopes that is limiting what is actually required by your building, and then can actually maintain the building temperature for longer periods of time. So that's a resiliency measure. Also, installing solar PV systems can provide electricity for systems when the grid is out, and pairing that again with battery storage systems can also just make that energy available if the grid is unreliable. And then finally, dual fuel systems can kind of help prevent issues if your systems are mainly electric. Having kind of a natural gas backup, say for your heat pump system, that can also help fight against difficulties with electricity outages. And I think that's all. So I know we are kind of out of time. I don't know, Melissa, if we've gotten any chat questions, but I know that I can stay on past the hour if we have some more questions.
I'm not seeing any questions in the chat right now. You could give people a few seconds to drop those if they have them. And one thing maybe I'll just mention real quick, also on our decarbonization webpage, we do have a community toolkit that kind of goes through some of the stuff we talked about today. So that might be a resource to look for as well. Well, I'm not seeing any questions coming through in the chat. So thank you guys so much for the presentation today. Thank you to all of our attendees for attending. And we hope this was helpful. Thank you all so much.
Thanks, everybody.